Hi there, welcome to Miss B's Math Academy. I'm Nina Benazar and I am the creator and founder of Miss B's Math Academy. I'm also a certified 6-12 math instructor. In this video, we're going to learn about
the law of sines and law of cosines. The learning goals students will use to derive the laws of sine and cosine and use them to solve problems. I'm gonna say right now, please take the time to write this down here and this right down. If you don't do it now, we'll present it again to you later on the video, but pay attention to have this in your notes somewhere. Have it written down, please, okay? Alright, so the three trigonometric functions or trig functions are widely used to solve problems that involve right triangles. And again, this is the law of sines right now, and you want to make sure you have this somewhere in your notes. Make sure you have it written down, please, okay? Notice that if this is A, okay, then this will be lowercase a. If this is C, then this will be lowercase c. And if this is B, we're talking about the opposite, right? So this one will be lowercase b. So we can also use the law of sines to solve problems with triangles that are not right triangles, aka, or also known as oblique triangles. Okay, notice that this here, even though it's not written to scale, this is not a right triangle, okay? So we're using the law of sines in triangles that are not right triangles. So given triangle ABC, measure of angle A, which is this one right here, is 77. The measure of angle C is 29. And BC, which is this one here, measures 15. Find the lengths of the unknown sides to the nearest tenth, okay? So we're trying to find, this is going to be A, right? Because that's across the uppercase A. This one will be lowercase c, and this one will be lowercase b. And again, let me move this out because I may have written down somewhere in there. Perfect. So we have sine of c over c. Okay, so sine of c, and this one right here, over c equals sine of a over a. We're going to substitute the values we have. We know the sine of c is sine of 29 over c equals the sine of 77 over 15. Okay? We're going to cross multiply and we get 15 times sine of 29 equals c times sine of 77. We solve for c, so that means we're going to divide both sides by sine of 77. And we get that c equals 15 times sine of 29 divided by the sine of 77. Again, we're going to put all of this in the calculator, and we get that c is approximate 7.46. Okay, so that is the measure of c. Now we're trying to find the measure of b, the length of b. And for that, we're going to establish a different ratio, again, using the law of sines. So we're going to do sine of a over a equals sine of b over b. We know the sine of a, sine of 77 over a, which is 15, equals sine of b, which in this case is 74, okay, over b. How do we know that this is 74, by the way? We know that this side is 74 because we know that all three of them have to add up to 180. So if you have 180 and you subtract 77 and you subtract 29 from it, that equals 74 degrees, and that's how I know that b measures 74 degrees, okay? We're going to cross multiply just like we did before, and we get b times sine of 77 equals 15 times sine of 74. And then we divide both sides by sine of 77, and we get b equals 15 times sine of 74 divided by the sine of 77. We put all of that in the calculator, and we get that b is approximate 14.80. Perfect. Alright, so now we're going to talk about the law of cosines. This one's a little bit more complicated in the format, okay? So make sure you write this down. It's very, very important. This is the same thing. Whoops. This is the same thing that I had on the picture before, okay, on the initial slide. Make sure you write this down, please. So if we have the law of cosine relates the cosine of each angle to the side lengths of the triangles, okay? So in this case, if you're trying to find a square, okay, a square equals b squared plus c squared minus 2 times b times c cosine of a, okay? And it goes like that for every side depending on where you are, okay? So again, let's take a minute to understand this one. This one here, a squared, is going to equal b squared plus c squared minus 2 times b times c in cosine of this angle right here. Okay? And if you were to move to a different one, you're gonna do the same thing, just in the different sides, okay? Alrighty, so we're gonna solve this problem. This is the last example, and we're doing this one using the law of cosines, okay? So you are given an air traffic controller is flying a plane 2.1 kilometers due south of the radar tower. A second plane is located 3.5 kilometers from the tower at a heading of north 75 degrees east north. To the nearest tenth of the kilometer, how far apart are these two planes? So I'm looking at a plane that is over here, and I'm looking at a plane that is over here, okay? We're trying to find that angle right there, and I know that this forms a straight angle, so that's gonna be 180 for measure of angle D, 180 minus 75, and you get that this angle here is 105 degrees. Knowing that information, I'm gonna use the law of cosine for angle D. Okay, so that way I can solve and find what D measure, which is what I'm trying to solve for. Okay, so that's gonna be using the law of cosines to solve for D. I get D squared plus A squared plus B squared minus 2AB cosine of D. That will be the formula. And now I'm just gonna plug in everything. So we get D squared equals A squared, okay, and I'm looking at plane A here. So that means A is going to be 3.5. So 3.5 to the second power plus 2.1 to the second power minus 2 that multiplies 3.5 times 2.1 times the cosine of D, which in this case is 105 degrees. This looks complicated. It's long. It's not that complicated. So let's multiply, put everything on the calculator for us. So we get D squared equals 3.5 to the second power, which is 12.25, plus 2.1 to the second power, which is 4.41, minus 2 that multiplies 3.5 times 2.1, so I'm going to multiply all of that, and I get 14.7 cosine of 105, and I add these two here, and I get 16.66, and now I'm going to put in the calculator 105 cosine, and then times negative 14.7, and actually get positive 3.8046, and add those two, and I get 20.4646. Now that's D squared. We have to do, to solve for D, we have to do square roots, right? And I get D is approximate 4.52379. So that means the planes are 4.5 kilometers apart. Perfect.
Thanks for watching Miss B's Math Academy, and I'll see you next time. Remember, the best way to learn math is by trying on your own. So practice, practice, practice. See you later.